Hello all, welcome to my engineering physics channel. In previous some sessions, we are started the unit number 1, Fundamental of Photonics. In previous session, we are discussed part 1, that is lasers. In today's session onwards, we are starting the part 2, that is optical fiber. So this is session number 4. In this session number 4, we are discuss about the optical fibers. It's in introduction, some basic concept, basic constructions of optical fiber, types of optical fiber, the difference between step index and graded index, and the derivation for acceptance angle and numerical aperture, then attenuation and factors affecting the attenuations and the communication system. So let's start the session. So what is the optical fiber? After the laser, the information or the data started to transmit by using the light. That means your information is transferred within the speed of light. So that the more information can be transmitted by using light instead of electronic signal. In open atmosphere, the light energy dissipates in a very short time. So the guiding channel is required for that transmission of data. So this is the optical fiber. The optical fiber consists of the three parts, that is core, cladding and the outer coating, which is known as sheath. So the central part, which is core, which is known as fiber core, which is made up of a transparent material which is fragile in nature, so that's why it is surrounded by the cladding material, which is also made up of another transparent material. And this optical fiber works on the principle of total internal reflection. It is also known as TIR. So for total internal reflection, your material which is used for core, its refractive index should be greater than the refractive index of cladding, so that the light enters and suffers a multiple total internal reflections and your data or the information will be transmitted. So the fiber optics is the technology in which your electrical signal is converted into optical signal. By using this core, your optical signal or the data or the information is transferred, and again at the output you will receive the electrical signal. That means your first electrical signal is converted into light signal or the optical signal, and that optical signal is again converted into electrical signal as the output. So this is all about optical fiber. Now we have to discuss some basic concepts related to the optical fiber. So the first concept is nothing but the refractive index. So the refractive index is nothing but the ratio of speed of light in the vacuum to the speed of light in the material. So the refractive index can be denoted by the letter mu. In some textbook or some reference book, the refractive index is denoted by the letter small n. So the refractive index is mu, which is equals to C upon V, where C is nothing but the speed of light in vacuum, which is 3 into 10 raised to 8 meter per second, and V is nothing but speed of light in a materials. For all known materials, mu is greater than 1. After rearranging this formula, we can write the velocity of light in a substance is expressed as V, which is equals to C upon mu. So next is, as we discussed, this optical fiber works on the principle of total internal reflection. That means if light waves enter at one end and it propagates from the length of the fiber and comes out from the other end of the fiber, so there may be some leakage due to the side walls of the fiber. The reason of confining the light beam inside the fiber is TIR, that is total internal reflection. So fiber obeys the law of reflection and refraction of light waves, and the light ray enters on the fiber at a small angle, follows the zigzag path due to the series of reflection. So before we studying the total internal reflection, we have to study the refraction phenomenon. So let's discuss the refraction phenomenon. In this diagram, this first part is nothing but refraction, in which mu1 is a refractive index of core and mu2 is nothing but the refractive index of cladding. This boundary is known as core cladding boundary, in which first diagram, your light ray is incident at an angle of theta I, and it will reflected and gives us the refracted ray, and the angle between this is theta r. That means if we incident a light at an angle of theta I at a core cladding boundary, it will gives us a refracted ray of angle theta r, in which your light ray is transferred from denser to rarer medium. So therefore the angle of refraction should be greater than the angle of incidence. Furthermore, if we increase the angle of incidence, your angle of refraction will get also increased. In second diagram, if we increase the angle of incidence, the angle of refraction will get increased, and which is equals to 90 degree. So this type of angle, this angle of incidence is nothing but the critical angle. So, the angle of incidence at a core cladding boundary for which a theta r, which is equals to 90 degree, is nothing but the critical angle. Or we can say that the angle of incidence for which theta r is 90 degree is known as critical angle. Furthermore, if we increase the critical angle greater than that of critical value, your theta r will also get increased. That means if your angle of incidence is greater than this critical angle, your theta r will get increased. So figure third part gives us a theta I is greater than theta c. Therefore, your angle of refraction will get increased, and we will see that the light ray will be reflect in the same media. This is known as total internal reflection. So the definition of total internal reflection is that when the angle of incidence is greater than the critical angle, your light ray will be reflected in the same media. This is known as total internal reflection. So for total internal reflections, the Ri of core, that is mu1, should be greater than the Ri of cladding, that is mu2. That means mu1 should be greater than mu2. And the second condition is the light incident at an angle of incidence theta, which is greater than theta c. That means the angle for which your light ray is incidenting is should be greater than the value of critical angle. So this is total internal reflection. From this, by using Snell's law, we can write as sine of theta I upon sine of theta r, which is equals to mu2 upon mu1. So this is by using Snell's law. Here theta I is nothing but the angle of incidence, theta r is angle of reflection, mu2 is the refractive index of cladding, and mu1 is nothing but the refractive index of core. So in second diagram, the angle of incidence, which is equals to the critical angle. So we can replace theta I by theta c, and the angle of refraction is 90 degrees. So the theta r will be replaced by 90. So sine 90 is 1. Therefore, this equation becomes sine of theta c, which is equals to mu2 upon mu1. So this formula we are using in the derivation of numerical aperture and the acceptance angle. So the next point is basic construction of an optical fiber. As we discussed, the fiber consists of three main parts, that is core, second one is cladding, and the third one is nothing but the coating. So your core material is made up of glass, which is fragile in nature. So that's why we need some extra covering or the protective layer above the core, that is nothing but the cladding. So light enters into optical fiber, undergoes successive total internal reflection and follows the zigzag path. So it is essential to construct the optical fiber so that the total internal reflection will be satisfied. So as shown in figure, this part is nothing but the core part in which your actual information or the data will be transmitted. And this innermost part, that is core, has the refractive index of mu1. It is surrounded by the dielectric material, that is cladding, whose refractive index is mu2. So this is outer jacket is nothing but your cladding material. Okay. Such that the mu1 should be greater than mu2. Therefore, the total internal reflection will be taken place. So this is the required condition. Your refractive index of core should be your refractive index of core should be greater than the refractive index of cladding. So what is the use of cladding here? So cladding is added to reduce the scattering losses at core surface and to enhance the strength of the fiber. It is also used to protect the core from absorbing surface contaminants with which it can come in contact. And most of the fibers are encapsulated in a plastic material called as buffer coating, sheath or jacket. So it is necessary to add up further strength. So this coating is nothing but the buffer coating or a sheath or the jacket, and which is used to enhance the strength of the signal, or we can say that it is used to protect our information or the data. And this second figure gives us the total internal reflection which is occurs in optical fiber at core cladding boundary. So this is the basic construction about the optical fiber. Thank you all. So please like, share and subscribe the video. Thank you.